Hi, I'm Elijah Spiker. Today we're going to be taking a look at the Williamson ether synthesis. This is a way that we can make some ethers that are not symmetrical, meaning that there are different numbers of carbon on each side of the oxygen in the middle. So what we'll have here is we will end up with a final product of that's what we'll end up with. Okay, so you can see here we have 1, 2, 3, 4, 5 carbons on this side of the ether. 1, 2, 3, 4, 5, and this actually should be 6 carbons here on this side of the ether. So you can see that there are different numbers of carbons here. So we can't use the sulfuric acid reaction that we've talked about previously to make this. So what we're going to do is we're going to go through the Williamson ether synthesis, talk a little bit about what happens, and go from there. Okay, so you're going to need some sodium hydroxide, and we've got that. I'm going to go ahead and erase some of this here. So sodium hydroxide. Okay, so we know that this hydroxide ion is negatively charged. What's going to happen is this hydroxide ion is going to abstract the hydrogen from the alcohol. Okay, so what's going to happen is this bond here is going to break, of course, and these the hydrogen is going to be taken, and these electrons here are going to be transferred to be lone pairs. And so then what we're going to end up with is we're going to end up with this alkoxide ion, and like this, where we have an oxygen with a negative charge. Okay, so the reason for that negative charge is, again, we took that bond and we broke it. We shoved those electrons onto the oxygen. Now we have our alkoxide intermediate. Okay. Okay, so then what happens here with the bromine? Well, let's figure it out. So we know here that this carbon attached to the bromine here, this alkyl halide, has a partial positive charge. And the bromine has a partial negative charge, right? And so what's happening is this bromine is pulling those electrons toward itself, and therefore creating that positive center here on carbon number 1. Okay, so what happens? Well, oxygen goes over and attacks that carbon number 1. And in the process of doing so, it will create a new bond with that carbon. Of course, that bromine is still attached. And so what's going to happen is here, this bromine will get knocked off. Okay, so what we're going to end up with is, so this molecule here, which is, we have here 1, 2, 3, 4, 5 carbons, and then 6 carbons. So we have a pentyl group and we have a hexyl group. But in this case, it's going to be alphabetized. So it's going to be hexyl pentyl ether. And in addition to that, we're going to have some bromine, a bromine ion. And that's from that bromine that's lost. So that's what we're going to end up with. So this is the Williamson ether synthesis. Not a terribly complex reaction. Certainly important to know when you're talking about ethers, to synthesize in this way. We'll talk a little bit next about some reactions of ethers, but for now, that's all I've got.